Hey stats, here we go. We've got section 3 today. This is all about uses and abuses of statistics. So, just a lot of information for you. So the abuse of statistics happens when data is represented in a misleading way. And there are a ton of ways people can do this, and it happens all the time. You can really get a number to say what you want it to. Here are all the ways, and then we're going to go more into detail about each one of them. So you can have self-selected surveys, small samples, precise numbers, guesstimates, distorted percentages, partial pictures, deliberate distortions, loaded questions, misleading graphs, pictographs, pollster pressure, and bad samples. So all of those are ways that we can mislead somebody into thinking a statistic is more drastic than it actually is, or a problem isn't as big as it actually is. So let's go over each one of them and figure out how we can misrepresent data. So self-selected surveys. This is when the respondents themselves decide to be included in the results. So you have the choice to participate. And usually what happens is in these self-selected surveys is only people with strong opinions participate. Okay, and that's one way that data can seriously be flawed, because you're either going to get the extreme left or the extreme right. You're not going to get anyone in the middle with kind of a mediocre opinion. Alright, so then another way of misrepresenting data is by taking small samples. This, although isn't always bad, it can be in some cases, because when we take a small sample, we have to make sure that the sample is unbiased and representative of the population of which it comes from. You can have a sample that may be large, but a conclusion is drawn about a subgroup that the sample may be extremely small. So it depends on what situation you're looking at for small samples, if they're good or if they're bad. So if you're dealing with a large population, that's fine, but just keep in mind that the sample that you take from that large population may actually be extremely small. So kind of a loophole in there. Right, so precise numbers. So in our head, if we've got a precise number, one that has a lot of decimal points, we tend to think, well, wow, that's got to be more accurate, right? Although sometimes an exact value might be used to instill a higher degree of confidence in its accuracy. So a lot of people are going to put more complex numbers out there because the regular Joe is just going to be thinking, well, that's a pretty accurate number. I'm going to go with that one. And it's not always necessarily accurate. It's just another way to mislead people into getting them to think a certain way or get them to decide something based on a number in front of them. Okay, on the flip side of that, we've got guesstimates. We've all done it before. We've guessed how many M&Ms are in a jar for extra credit points or to win that jar of M&Ms. However, the errors in this we know can be substantial. And we need to consider the source of the estimate and how it was developed. So think about that jar of M&Ms. Some of us might just look at it and go, there's 1,000 M&Ms in there. Some of us might try and calculate volume of it and then figure out how many M&Ms would be in it that way. Okay, so we need to consider how that estimate was derived and how it was developed. So then we have something called distorted percentages, and this is just misleading or unclear percentages. We're not really sure what they mean, what they're proving. They're kind of vague. Those could be used to paint partial pictures, but partial pictures is another way, and this is just a claim that are technically correct, but they're leaving out information. Okay, so distorted percentages deal with unclear percentages. Partial pictures, you're just not given all the information. So if you think back to solving word problems, some word problems that we might solve, we can't because we don't have all the information. That's an example of painting a partial picture. So then we have people that are going to deliberately distort data, and this is telling you a lie just to get you to believe that one product is better than another. So this is like listening to infomercials. They're going to tell you their product is better because they're trying to get theirs to sell. So then you've got loaded questions. So this is when we take surveys, and the survey questions are worded explicitly to get a desired response. And I think we're going to do a little bit with this chapter just to see how data results can be skewed based on loaded questions. Sometimes, though, they're unintentionally loaded by how items are being ordered in a question. So sometimes people don't know the question's loaded. So that's why you have to be extra careful with how you word your surveys or word your question that you're asking. An example of one would be, would you say that traffic contributes more or less to air pollution than industry? And that's getting you to probably answer that traffic is going to contribute more because that's at the forefront of the question. By the time you've gotten to the end of it, you've not even heard industry. You're now thinking of everything that traffic does. You've got your emissions, you've got the diesel, you've got everything that comes out of a car, and you're not thinking about industry anymore. So that's an example of a loaded question. All right, we should almost be done with the explanations. We got misleading graphs. This is a bar graph or a pie chart that's used to exaggerate or de-emphasize the true nature of data. So if we look at this example down here, we've got this graph that's showing the same data, believe it or not. But when you're asked to find favorite foods here, if you look at the graph on the left, graph number 1, it looks like hot dogs are the far and away winner. But if you look at the graph on the right, it looks like there's really not a huge difference between pizza, hot dogs, and hamburgers. Well, also, if you look at your y-axis, the number of votes or the number of people surveyed, you'll notice that the scale there on the left starts at 950 and on the right starts at 0. So there are different ways that we can get graphs to show anything we want, a big discrepancy or no discrepancy at all. So then we have pictographs. This is when we use a drawing or money bags or cows or houses or whatever to create false impressions. So instead of bars, we're using actual objects. So like here, we have a graph that's showing us that the amount of trash the average American throws out has grown substantially from 1960 to the year 2000, because when we look at this, your eye immediately goes to the size of the trash can. You're not analyzing any of your axes, so pictographs can be misleading. Then you have something called pollster pressure. And this is when survey subjects are asked questions. They often provide responses that are favorable to their self-image. So when somebody asks you a question, you're going to turn it personal and you're going to ask it or you're going to answer it so that your self-image is positively promoted. Well, then we can also take bad samples, and this is common to analyze data and form conclusions that are wrong because of because the way that we collected the data was poor. Okay, so we could get bad results because we took a bad sample. For example, this would be asking people to call in for a survey, but the phone call costs extra to make. Well, you're not going to get a good sample of people because not everybody's going to want to pay that extra cost just to make that question, regardless of how strongly or how weakly they feel about the question being answered. All right, so some examples we have to think about. So we want to determine and explain how the data in each situation is misleading. So we've got 72% of Americans squeeze the toothpaste tube from the top. This and other not-so-serious findings are presented in the first really important survey of American habits. Those results are based on 7,000 respondents from the 25,000 questionnaires that were mailed. What's wrong with this survey? You tell me. Okay, well, this survey was mailed so that those who had time to respond could. You might not have made it clear for the intended response. All right, and the last example I want you to think about on your own. So go ahead and